Okay, so you got a hammer and a feather drop from the same height. They will accelerate at the same rate. The question is why? Most of you guys said because in the absence of air friction, everything is going to fall at the same rate. Okay, guys, while it's correct, that's not the answer to that question. Okay, you can't repeat part of the question as an answer. The reason why everything falls at the same rate and don't use equations is because how fast the object falls will depend on the mass of the planet, and it's also going to depend on the size of the planet. That's it. So G is going to depend on the mass and the size of the planet. Simple, straightforward answer. It's going to be directly proportional to the mass. It's going to be inversely proportional to the size. Either answer is fine. Okay, so the mass of the planet is constant. The size of the planet is constant. Okay, so that's the reason why the mass of the falling object doesn't matter. The only thing that matters is what determines how fast something is going to fall is the mass and the size of the planet. All right, so the next question is, if gravity extends all the way out to the moon, why then do astronauts feel weightless? Force of gravity is what gives you a weight. All right, astronauts are not weightless. They will feel weightless because they're experiencing free fall in the form of projectile motion. Trajectory of their motion is matching the curvature of the surface of the Earth. Okay, most of you guys made generic statements saying they're in a free fall. What does that mean? You have to kind of explain it. All right, because when somebody says free fall, you're thinking something is falling downward. In reality, in this case, it's free fall in the form of projectile motion. And in free fall, everything falls at the same rate. All right, as a result, they will feel weightless. Okay, question number 3. You're inside an elevator and the cable snaps, and the elevator falls 300 feet before it's brought to a stop by a magnetic safety system designed to attenuate its motion. So which means that it's brought to a stop gently. That's what it means. As a result of the fall, the person has a broken neck. So the question is, how did this person break his neck? Once again, guys, it's a free fall. The elevator is going to be in a free fall for 300 feet. So what happens? Person is going to appear weightless, feel weightless inside of falling elevator. The reason why that happens is because the elevator and the person inside are in a free fall. They're going to be accelerating at the same rate. Okay, so the elevator and the center of mass of the person is going to be accelerating at the same rate, so which means that the person becomes suspended with respect to his or her center of mass. All right, so now it depends on what the person does. If the person moves inside the falling elevator back and forth, the body gets out of position. When the safety system kicks in, when your body's out of position, you will fall. Okay, and you can potentially break your neck. You can try to jump. You can push up against the floor. Obviously, it's going to give you a relative speed. Relative to the elevator, you can go up and hit the ceiling and come back down. When you're going up and down, it's very slow motion, so it wouldn't harm you, but at some point the elevator comes to a stop. Remember that. And if your body's out of position, you can hurt yourself. Or if you try to get your body parallel to the ground by actually pulling your legs in, you may start to slowly spin. You may be upside down. So what I was looking for, a simple factual explanation. The person becomes suspended with respect to his or center of mass because it's a free fall. He's falling at the same rate as the elevator is. And if the person moves, the body gets out of alignment at the time of impact. Or even if you're moving, not a big deal. You can still lose your balance at the end. Okay, so what I was looking for is some kind of a factual explanation. It didn't have to cover everything, but it needed to cover one of them, one of the possibilities fully. All right, I think a lot of you guys end up losing points on that one. So you got a space station in circular orbit around the Earth. It's got no artificial gravity. All right, so there's a book on a table. And then what you do is you slide the book across, which means that you're letting it go. Is there any frictional force acting on this book? All right, once again, the explanations were kind of weird from some of you guys. The answer to that question is going to be no, because frictional force depends on the apparent weight. The book is in a free fall, just like the astronaut, in the form of projectile motion, which means that this represents apparent weight. This book will appear to be weightless. If there's no apparent weight, there's not going to be friction, which means that it's not going to be touching the surface in essence. Okay, so those of you guys who lost points, it's not that you didn't. Most of you guys got the concepts right. Your explanations are a little bit wrong. You said the book is weightless. The book is not weightless. The book still weighs something. It's got gravity acting on it. The book appears weightless, all right, because it's in a free fall. Okay, so that explanation was kind of missing. And then we got question number 1 in the video shown during the lecture. We got a monk, and you guys have seen the monk. He was able to levitate by slowly rising from the ground and hovering above the ground for nearly a minute. Okay, so was that real levitation? Okay, the short answer is of course not. Because if it were real levitation, what would have happened? He would have gone in a straight line at a constant speed. He would have been projected out into space. Okay, now you have to explain why he would be projected out into space, because the reason is because the Earth is spinning, guys. You're moving with the Earth in the same direction. Real levitation would have looked like that. Okay, so that was one of the explanations. The other explanation is obviously you cannot overcome gravity mind over matter. It's out of the question because internal forces will not cause an acceleration. All right. Another answer is you're trying to overcome capital G, which is the strength of gravity, but in reality, you're trying to overcome the strength of gravity. Well, multiplied by the mass of the earth divided by the size of the earth squared is going to give you roughly about 10. Multiplied by your mass is going to be your weights. You can't overcome something like that. Okay, any of those answers would have been good enough. I think most of you guys kind of got this right. Okay, so